Hey guys, this is our 7.5 section in our trig unit, sum and difference formulas. So I'm going to give you a couple of these identities. Okay, formulas is also another word for identity. Okay, so the first one is called sum and difference formulas for cosine. So I need a pen. Here we go. Let's do the sum first. Sum of two angles. Let's call this alpha plus beta. Okay, now alpha and beta are just two Greek letters. It's like A and B. Now if you can see this, okay, this is not distributive. So if you write this, it's a big no-no. Okay, so I'm gonna bubble this up and saying that this is not okay to have. Okay, but what it is equal to is, okay, so sum and difference of alpha plus beta. So let's say you have 30 degrees plus 60 degrees. Okay, so technically that's 90 degrees. So cosine of 90 degrees you can totally find. But what if you have angles like 15 degrees plus 45 degrees? Okay, that's 65 degrees. You can't really find that. So that's why we will use the sum and difference formulas. So cosine of alpha plus beta is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Okay, so I'm going to use a highlighter. I'm highlighting this formula and it equals to this. Okay, then what if you want to subtract? Cosine of alpha take away cosine of beta. The formula is really similar. Here we go. It's going to be cosine of alpha times cosine of beta. Now, because in this equation there is a subtraction, I know. Now I'm changing the sign to addition. So now it's the same thing except the signs are switched. Okay? Now, keep in mind that this is not the same. Okay? This right here is not cosine of alpha minus cosine of beta. Big no. Okay, so keep in mind that piece. Now what if you have the sum and difference formula for sines? So we are going to do sine of alpha plus beta. Okay, we are now going to do, it's slightly different from cosine. So we're going to do cosine. You know what, let's do sine first. There's nothing wrong with what I'm writing. I just want to put it in order. Okay, so I want to do sine of alpha. Now it's not times sine of beta. It's times cosine of beta. Okay, then this is plus cosine of alpha times sine of beta. Okay, so for this one, for sine, if it's addition, then it's addition here. Versus cosine, if it's subtraction, it's really addition. If it's addition, it's really subtraction. For cosine, the signs are switched. But for sine formulas, the signs, okay, the addition and subtraction, the sum and different signs are the same. So I'm going to do sine now of alpha minus beta. Okay, everything's the same except this right here. Okay, so we're going to fill in sine of alpha cosine of beta minus cosine of alpha times sine of beta. Okay, so the last two formulas, they are for tangent. Okay, so tangent of alpha minus beta is, now this is going to be a fraction, so I'm going to be very cautiously writing this slowly. So tangent of alpha plus tangent of beta. Now all of this, let me make this line fatter. Okay, all of this is divided by, that doesn't look so good. Shoot. Maybe I don't need to be that fat. Okay. Maybe not that fat because that took up the entire space there. Okay, let's try that one more time. Maybe skinnier. There you go. All right. So tangent of alpha plus tangent of beta all over. Okay, that means dividing 1 minus tangent of alpha times tangent of beta. Okay, so go ahead and write that down. Then I'll just wait for you. Okay. Then, now we are going to work with tangent of alpha plus beta. So now let's take notice. This is a subtraction, okay? So, oh, I take that back. If it's a subtraction, can you fix this for me? This has to be a subtraction on the top. If that's a subtraction, that has to be a subtraction, and this is a plus. So make sure that's okay. So let's double check. So if that's a subtraction, this has to be subtraction, okay? And then that means this is the opposite, okay? So I want those signs to be right. Okay, so next, we're doing addition. So if it's an addition, the top would be the same, which is addition. So that's what I got wrong earlier, okay? All over. Now the bottom will switch, okay? So that's what we needed, okay? Okay, let's do example number 1. Find the exact value, that means you cannot use a calculator, of the following. Cosine of 7 pi over 12. Now, anything over 12 is not what we know from the unit circle. We only know multiples of pi over 2, pi over 3, pi over 6, pi over 4, okay? But pi over 12, multiples of pi over 12, we don't know. So what you need to think about is this, okay? You need to turn this into adding or subtracting of two angles that will also give you 7 pi over 12. So I'm going to try, let's see, 3 pi over 12 plus 4 pi over 12, okay? Now, could I technically, let's just say that if I don't know, what if I want to try pi over 12 plus 6 pi over 12, okay? So let's do this. Pi over 12 plus 6 pi over 12, okay? Well, okay, well, what happened when I reduce? And of course, in math, you always reduce. I can't reduce pi over 12 anymore, so I can't do much, but 6 pi over 12 is a pi over 2. So even though you know this angle, you can find this angle from this unit circle, but you can't find this, so this is not a good sum, okay? So that doesn't work. So you want to try a different one, right? Cosine of, well, let's try 2 pi over 12 plus 7, so I need 5 pi over 12. Okay, so that would give me 7 pi over 12. These right here, this right here has to be the same as your original, okay? They can't be different. Okay, well, let's try to reduce. So that's really cosine, well, 2 pi over 12 is pi over 6. So now I can do that. But 5 pi over 12, I can't reduce that anymore, so that doesn't work either, okay? So now I'm going to try the next one. Cosine of 3 pi over 12 plus 4 pi over 12. Okay, well, let's reduce. Cosine of 3 pi over 12 is really pi over 4 plus 4 pi over 12, that's really pi over 3. Whoa, I know both angles, okay? So now what you need to do is use sum and difference of cosine, okay? Well, this is really your alpha and this is your beta. And the sum and difference formula says, here we go, cosine of alpha plus beta equals, can you tell me what the formula is? Cosine, very good, of alpha times cosine of beta. So far so good. We are adding, so in cosine, this is the opposite. Sine of alpha times sine of beta, okay? Then we fill it in. Cosine, we have pi over 4 plus pi over 3, okay? Then we fill in, this is alpha, this is beta, so here we go. Cosine of pi over 4 times, oops, I'm missing a cosine right there, times cosine of beta, beta is pi over 3, minus sine, alpha is pi over 4, and beta is pi over 3, okay? Then from here, you need to simplify. Cosine of pi over 4 is radical 2 over 2 times cosine of pi over 3 is, can you please give me that value? Did you say 1/2? Okay, I'll take 1/2. Sine of pi over 4 is about 2 over 2. What's sine of pi over 3? Okay, about 3 over 2. If that's what you said, then you're right. If you wrote something else down, then please correct it. Then from here, we will distribute. So we would have rad 2 over 4 minus rad 6 over 4. So we come up with radical 2 minus radical 6 over 4. And because we can't use a calculator, this is as far as we can go. All right, let's try the other one. Now you have cosine of 15 degrees. And yes, we can mix between degrees and radians in these ones, okay? So, well, you can do a lot of different things, okay? You can subtract, you can add. So the easiest angle for me to use is really cosine of, let's do 60 degrees, take away 45 degrees, okay? I can also do cosine of 45 degrees, take away 30 degrees. And I can do a bunch of different ones, like cosine of, let's say, 135, take away cosine, take away 120, right? So all of those will work. All right, but for this one, we're going to use this, okay? Here we go. This is a difference of two angles for cosine. So this is alpha and this is beta. And the formula of difference of cosine is cosine of alpha minus beta is, go ahead and write that down for me. Okay, so the formula for the difference of cosine is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So from here, we would now enter in alpha is 60 degrees, cosine of beta is 45 degrees, plus sine of alpha, alpha is 60 degrees, and sine of beta is 45 degrees, okay? Well, cosine of 60 degrees, why don't you tell me what that is? 1/2, okay. Cosine of 45 degrees? About 2 over 2, good. Plus sine of 60 degrees, about 3 over 2, good. And times about 2 over 2. Let's simplify this. This is about 2 over 4 plus about 6 over 4. So this is really about 2 plus about 6 all over 4. Okay. Look at these answers, okay? I want to make a connection between these two. Can you see that these two answers are, look at this. The only difference is what? It's the sign in the middle. See that right there? So that's why it's important for you to get the correct answer in trig. There's no, if you get the wrong angle, then your answer, even though the sign is the only that's different, but it's the whole answer is wrong because now you're in the wrong quadrant. So that's why it's so important to check your work in trig, okay? It's important to check your work everywhere, but especially in trig. What if I use this right here? Do you think I will still get exact same things? Let's check it out, okay? So this is now your alpha and this is your beta. So cosine of alpha is 45 degrees. My cosine of beta is 30 degrees. Because this is cosine subtraction, we now add sine 45 degrees times sine of 30 degrees, okay? And cosine of 45 is about 2 over 2. Cosine of 30 is did you say about 3 over 2? Okay, I'll take that. And we are going to add about 2 over 2 for sine of 45 times sine of 30, 1/2. So now we have rad 6 over 4 plus rad 2 over 4. And guess what? Look at the answer. This is exactly the same. Whoa! Cool, right? Okay. So that's how we use the sum and difference of cosine to find the exact value when the angle that's given to you is not a multiple of pi over 3, pi over 6, pi over 2, you know, any one of those ones that we know, okay? I'm going to skip C right now and then do D because I might have you do C as a warm-up or an assignment in class. So let's do D. Tangent of 195 degrees. So can you tell me what two angles that I can use, okay, without a calculator, that can add or subtract to 195? Okay, so what I normally do is, the thought process is this, okay? I'll start with 30 degrees, okay? And 30 degrees add what? It's 195. I'm sorry, tangent of 195. So let's see, that's 165. It's 165 an angle that we know. So that's really the question that comes down to it. And this, even though we know 30, we don't know 165. How about if I use tangent of 45 degrees plus, what do I need to add to 45? 150? Okay, now that's okay. That's something that we can work with, okay? So the formula for tangent of alpha plus beta is, can you give me that formula, please? It's an addition here, okay? So we will start with an addition on the numerator, okay? So tangent alpha plus tangent of beta. Now that we know that what that is, we now can divide, and the bottom has an opposite sign. Okay, so this is right here alpha, and this is beta. Let's plug it in, okay? So tangent alpha is 45 degrees. Make sure you write the bubble. And tangent of 150 degrees all over 1 minus tangent of 45 degrees and times that to tangent of 150 degrees. Okay, here we go. I love tangent of 45 degrees because I know that is 1. Is that cool? Plus tangent of 150. Okay, so let's see what 150 is. 90 is right here. 150 means I need to add 60. So my reference angle is 30 degrees. Okay, 30 degrees, I mean, this is 1, this is negative rad 3, and this is 2. So tangent is opposite over adjacent. So that's really 1 over negative rad 3, which is really negative rad 3 over 3 for tangent of 150. Okay, so from here we will divide. 1 minus, I already know what tangent of 45 is. Oops, I didn't mean to do that. I want to highlight that. I know that tangent, red, since I have, okay, so tangent of 45 degrees is the same as that, so that gets 1, okay? So that gets a 1 value right there, okay? Then another highlighter, how about this one? Tangent of 150, that's the same, and that's right there. So I'm just going to go in and write negative rad 3 over 3, okay? And now we just need to simplify, okay? Here we go. I'm going to need to, on the top, I need to find the common denominator. So the common denominator will be 3 over 3. 2, a positive and negative is now a negative, okay? Oops, this is 3. All over 1, okay? Negative 1 times a negative is now a positive, rad 3 over 3. And I'm going to simplify some more. Then from here, on the top is 3 minus rad 3. Denominators are the same, so I'm going to put it over 1. I'm going to write this line right here as a division then this way. And I'm going to find the common denominator again for the bottom. So it's 3 over 3 again, plus rad 3 over 3. Okay, denominator the same. So I can multiply by its reciprocal. Okay, which is now 3's on the top. Okay, so these 3's will cancel. So we are here. Now, notice how I'm almost done, but there's a radical on the bottom. The radical on the bottom means I need to rationalize that, okay? That means if you have more than one term, go and put parentheses around it. To get rid of this, you want to multiply by its conjugate. Okay, what is the conjugate? The conjugate means this sign right here and this sign is the opposite. Okay, what you multiply to the bottom, you multiply to the top. And let's work this out cautiously. Do your algebra work carefully. 3 times 3 is 9. 3 times radical 3, negative rad 3 is negative 3 rad 3. In the middle, another negative 3 rad 3. The end, negative rad 3 times negative rad 3 is positive 3. On the bottom, because they are conjugates, they are much nicer, okay? That means you only have to multiply the first 2 terms and the last 2 terms. The first 2 terms give me 9. Negative rad 3 times positive rad 3 is negative 3. So simplify some more. 9 plus 3 is 12. Minus 6 rad 3. Yes, you can combine radicals if the radicals are similar. And 9 minus 3 is 6. I'm going to factor out a 6 from here. That leaves me with, what's that? 2 minus rad 3 all over 6. Reduce that. I end up with a nice answer of 2 minus rad 3. Okay? So, yes, you have to rationalize your denominator. Example 2 in 7.5 notes. The direction says find the exact value of each. That means you may not use a calculator. So if you look at the expression, cosine of 40 degrees times cosine of 80 degrees minus sine of 40 degrees times sine of 80 degrees. And you can't use a calculator because the direction says find the exact value. So how is that possible? How is this possible? We don't know 40 degrees. We know 30 degrees. We know 45 degrees. We know 60 degrees. And we know 90 degrees and all the multiples, right? How do they expect us to find cosine of 40 degrees and cosine of 80 degrees without a calculator? Do you see or do you recognize this expression from one of the identities that we have written somewhere up here? Up here. You mean this? What? Wow, yeah, that's what we're going to use. Here we go. We are now going to go backwards, okay? Cosine of alpha, this is the identity that we wrote above, times cosine of beta minus sine of alpha times sine of beta. According to the identity, this is a sum of cosine, okay? So what does that mean? It means that alpha, okay, is 40 degrees and beta is 80 degrees. So I'm going to use this right here. So cosine of alpha plus beta is really cosine of 40 degrees plus 80 degrees. Oops. Which is cosine of 120 degrees. Yay! Okay, 120 degrees, it's in quadrant number 2. So I know my answer is going to be negative. And from your unit circle, you should know that it is a negative 1 over 2. Okay, now I would like for you to attempt B on your own. So if you're watching this video right now, I would like you to pause it, or the person that's in charge of the class, pause it right now so you can come up with an answer. Now that you have tried it on your own, let's work it out together. So according to the expression, tangent of 40 degrees minus tangent of 10 degrees, all divided by 1 plus tangent of 40 degrees times tangent of 10 degrees. Because the numerator has a minus, according to my formula that we have written up here, because it starts with a minus, I know that this is a difference. See this right here? This is a difference of tangent. So I'm going to write the identity first, okay? So tangent of alpha minus tangent of beta all over 1 plus tangent of alpha times tangent of beta. This equals to the difference of alpha minus beta, okay? Well, I know that 40 degrees is alpha and 10 degrees is beta. So that's what I'm going to write. Alpha equals 40 degrees and beta equals 10 degrees. I'm going to use the formula. Tangent of alpha minus beta is tangent of 40 degrees minus 10 degrees, which is tangent of 30 degrees, okay? So 30 degrees is in quadrant number 1, okay? So it's going to be 1 over 2. I'm sorry, not 1 over 2. What am I saying? I was looking at sine. I want tangent, which is opposite, opposite over adjacent. Okay, so opposite is 1 over adjacent. It's rad 3, so this is really rad 3 over 3. Okay. All right, so this is it for this video. So I'm going to give you a little joke before we end the video. What did the picture say to the wall? So what did the picture say to the wall? I have been framed. Get it? The picture has a frame around it. Ha ha. All right, until next time.